In today's Solarpunk Presents bonus clip, which goes along to the episode about Solarpunk Farms' regenerative farming efforts, we're going to talk about soil. None of us would be eating without it, and yet we tend to treat it like dirt. So first off, what is soil? And how is it not just dirt? According to the Soil Science Society of America, soil is a mixture of minerals, organic matter, air, and water. Organic matter, in this case, is mainly referring to the still living or now decaying non-mineral parts of living things. They're carbohydrates, lipids, and proteins, and the building blocks of proteins, essentially. The non-living organic matter in soils, as you might imagine, consists of a lot of cellulose and lignins, those woody, hard-to-break-down structural materials of land plants. Another defining feature of soils is that the mixture that makes up a soil has to have undergone some physical, biological, and chemical weathering, because a soil is a very particular creation of a local time, place, climate, and situation. All soil has been made from some sort of parent material. This can be huge, solid bits of rock, be it something like granite, sandstone, or limestone, known as bedrock. More often, it's a layer of rock that has already been broken up by a bit of physical weathering. All that extra surface area makes it much easier to work on. So, as you may be suspecting, soils are not static. They're constantly forming and constantly changing as creatures burrow through them, plants take up nutrients and exude carbon dioxide and other waste products as rain percolates through them, or during the dry seasons they dry out. Minerals are constantly being broken down to produce clays and solutes, and air is constantly, slowly diffusing in and out of the soil profile, helping to keep things oxygenated. You could say that step one in making a soil is breaking down bigger rocks into grain sizes more suitable to be a soil, sand-sized, for instance, or smaller. This can happen through processes like erosion, freeze-thaw cycles, or even by biology, like plant roots or burrowing animals getting in there into cracks and wedging them apart. What you get out of that is a layer of soil known as the C layer, or the parent layer of soil. The next layer to develop is the A layer, or topsoil. As plants and soil organisms move in and, aided by air and water, get increasingly to work on the materials of the parent layer, they alter it. Roots break the rock material further up and exude carbon dioxide and organic acids that get to work on dissolving or chemically altering the grains of rock. Soil solutions pick up solutes. Clay minerals begin to form. Soil organisms, from bacteria to fungi to animals, which are anywhere from microscopic to merely small, move in. Organic matter begins to accumulate and then to decay, releasing nutrients into the soil. Eventually, this topsoil develops into a luscious mix of minerals and organic matter that is full of nutrients and is a wonderful place for plants to thrive. Next, you start to form the E and the B layers of the soil. As water percolates through the A layer, it can leach out clays, organic matter, and certain minerals, leaving behind grains of more inert minerals like quartz. Not all soils will have this leached out horizon, known as the E layer or elucidated layer, but when it forms, it will do so at the base of the topsoil. Next comes the B layer, also known as the subsoil, which is where the leached materials accumulate. It has less organic matter than the A layer, and biology is far less active here. It also tends to be reddish because of its accumulation of iron oxides. Underneath the B layer is now where you can find that C layer that served as the source material for the soil. If you dig down into a soil, creating an undisturbed vertical wall that allows you to look at the soil's profile, you'll immediately see these layers. A on top of E, on top of B, on top of C, maybe on top of bedrock. All of these are known as the horizons, since they're horizontal, and they are a non-negotiable feature of soils. Without the horizons, you just have dirt, which is no longer soil because it is just something someone dug up and dumped somewhere. Dirt is out of context, unstructured, and divorced from its origin. People who are really into soil are really into soil, and they have identified no less than 12 different main categories of soil and thousands of individual soils. Recognizing the different soil types helps us better understand the ecology of natural areas, as well as helps us optimize our farming and gardening practices. Just to run through them really quickly. There are gelisols, which are permanently frozen, or they contain permafrost near their surface, and these occur in polar regions. Histosols are seriously organic, forming in bogs, moors, fens, and peatlands, where organic debris piles up faster than it decomposes. Spodosols form when leaf litter, like pine needles, react with rainwater to form organic acids. These soils are acidic, poor in nutrients, and terrible for growing anything that isn't a conifer. Andesols, in contrast, the beautiful black soils that result from the weathering of volcanic materials like ash, are fantastic for growing things in. Oxisols, which form in the tropics and subtropics, are dominated by clays, iron oxides, and quartz. They're not great for growing things until you change them by adding lime, calcium oxide, and fertilizers. Vertisols are super fun because they contain clays that shrink when they dry out and expand when they get wet. So don't build a house here or anything else. On the other hand, they're fertile, although you have to deal with the fact that they tend to get waterlogged at their surface. Iridosols are what you get in deserts, where weathering is severely limited by water. There is lots of gypsum, salt, and carbonates that have accumulated in these soils. Ultisols are intensely weathered soils, with their nutrients confined to the top couple of millimeters. These tend to form in humid regions. Alphasols are the slightly less weathered, slightly less acidic cousin of ultisols. Mollisols are prairie or grassland soils. Inceptisols, and is that a great name or what, are only moderately developed soils without much in the way of clay in their subsoil yet. This is one of the largest groups of soils on Earth. Entisols haven't even made it to being inceptisols yet. They're so young and immature, all they have is topsoil. Since basically every type of soil has to go through an entisol phase as it develops, this actually represents the largest group of soils on Earth. Here's another one for the people who really love soils department. Because soils are so important to us, both in terms of feeding us and in that sense serving as the basic basis for our economies, a lot of the states in America have adopted an official state soil, as I mentioned in the episode. So for California, for instance, it's the San Joaquin soil, which is found throughout California's Great Central Valley, the seat of quite a lot of its agriculture. The top layer of San Joaquin soil is a reddish loamy layer, meaning it's made up of a mixture of sand, silt, and clay, and it also happens to be rich in organic matter. The layer under that is similar but lacks the organic matter. The layer under that one is a reddish-brown clay, or a clay loam layer, that exhibits sort of this weird pillar-like structure. Because there's so much clay in this layer, it inhibits water and plant roots from extending deeper into the soil. Beneath this, at depth of half a yard or half a meter, or maybe up to a full yard or a full meter, is a hard pan, or durapan layer, made of clays that have been cemented together by silica. Plant roots and water definitely don't penetrate through this layer, which can extend down another 1/2 to full meter. The San Joaquin soil has been so thoroughly physically and chemically modified via farming and other practices, it can be argued that there are no pristine patches of it left. And maybe that means that this soil type is actually extinct, if you want to look at it that way. Although, if we started to leave it alone, it would, over time, go back to being what it had been before. If you're curious about Alaska, its state soil is Tana soil, which is full of permafrost. The state soil in Kansas, the Harney soil, is a silty loam formed from loess, which are sediments that have blown in on the wind. In Texas, the state soil is Houston black soil, which developed from calcareous clays and marls that were deposited during the Cretaceous, during the rise and retreat of inland seas. And that's a great example of a vertisol, which makes it a difficult soil to manage. In the northeastern U.S., a lot of the state soils, are derived from glacial deposits left behind when the northern hemisphere ice sheet retreated at the end of the last ice age. So, such as the Lester soil of Minnesota, the Kalkaska soil of Michigan, the Haneaye soil of New York, and the Chisencook soil of Maine. Georgia's state soil is the Tifton soil, which formed from loamy coastal marine sediments. And Washington State's state soil, the Tokul soil, is an andesol formed from volcanic ash. So 3 cheers for the sheer diversity and utter importance of what is an unintended consequence of climate, air, and water meeting rocks, meeting biology. Soil! And right now, Earth is the only planet in the solar system that actually has any. All the other planets just have dirt. Or, if you want to be technical about it, you can also call it regolith.